Welcome. In this lesson, we are going to talk about Java references. Let's get started. We've got two learning goals for today. The first is that you can explain how Java stores objects as references, and the second is that you can explain the concept of a null reference. In order to understand how Java stores objects as primitives, we need to understand how Java stores things in general, and we'll start by talking about primitives. On the right, you see a representation of Java's main memory. You can kind of think of the memory as an array divided into slots, and when we make a variable, this is where our variable lives. So for example, let's say I made a variable int x and assigned it the value of 5. What Java would do is it would go to the main memory and it would find an open slot. It would label that slot x and it would store in that slot the number 5. Maybe I make another variable, char ch, and set it equal to a question mark character. Java would find an open slot, label it ch, and store in that slot the character question mark. Now, of course, we know that variables can change. So suppose I said x equals -7. Now, previously x was 5, and so Java would go to the memory slot for x and update it so its value is now -7. Now let's see how Java stores an object in the memory. So we'll make a string str and set it equal to the word, the object, avocado. Just as before, Java is going to find the next available memory slot and label it str. But here's where things get different. Because the object avocado is actually too big to fit in one memory slot. If you think about it, our question mark, one character, took up one memory slot. And avocado has 7 characters, so we need 7 memory slots. So Java cannot fit the entire word avocado in this space. So what happens? Well, Java actually puts in the memory slot what is called a reference. And this is what it looks like. So again, notice that avocado is there, but it's not in the memory slot because the memory slot can't hold it. For now, we can think of a reference like a link on a web page. When you access a link on a web page, it takes you to a different location, and that's how references work in Java. When we access the variable str and we go to the memory slot, we don't find the object, but we find a reference, a link that will take us to where the object is actually stored. An arrow is a really useful way to visualize a Java reference, but of course that's not what's really happening behind the scenes. So on the right you can see a picture of the main memory, and it turns out that the memory is labeled with addresses. Much like houses on a street would each have an address, every memory slot in the computer has an address, and they kind of look like this. Notice that I've labeled the first memory slot, well, basically 1, and memory slot 1 is the variable x and it stores a -7, and memory slot 2 is the character ch and it stores a question mark. But when we get to the reference, we notice something different. So our string, which remember was too big for the memory slot and it's an object, it's stored at memory slot 3, but memory slot 3 doesn't contain the actual value of the object. Instead, it contains another memory address. So somewhere else in the memory, there is a spot labeled 123, and it has the information for the word, the string, the object, avocado. So why again are objects stored as references? It's basically because when we're dealing with objects, they have multiple values and methods, which makes them too large for just a single memory slot. So the reference that's stored in the memory points us to where the actual object is, and from there, Java knows how to access all of the variables and methods for that object. Now, the details of how this works, so in other words, once we follow the reference and get to the object, how Java knows to tie it all together and what memory slots go with that object, that's way too complicated for this course, but we can trust that Java has it taken care of through a process called dynamic memory allocation. Let's summarize our discussion so far. And it may sound like I'm being really repetitive and slow here, but understand that for a lot of students, references are a challenging concept. and they come up throughout the remainder of the course. So it's really important that we lay a clear and concise foundation here so we have something to build on. All variables are stored in memory slots. Primitives are stored directly in their slot, and we can see that with X, and we can see that with the char ch. But for objects, it's different. The memory slot of an object contains a reference to the actual location of the object. The objects are stored elsewhere. So str, the memory slot, points to where the object is. So str and rect are not objects technically, they're object references which refer to objects. One thing that you may not have considered now that we understand that objects are stored as references is the fact that an object reference might not have an object. So here's an example. I make a string str2, but I don't assign a value to it. And when an object reference doesn't have an object, it refers to what is known as null. So str, the object reference, has an object that's been created, the word avocado. str2 has not been given an object, so it simply refers to null. As soon as we assign an object to our reference, we no longer have a null. So I say str2 equals this string avocado, and notice that when we look at the memory, the null has been replaced by this new object. And keep in mind that even though str and str2 both hold the word avocado, they are two separate objects. Null is actually a word that Java understands, and I can use the word in my code to do a couple of different things. For example, if maybe I no longer want to refer to an object, I could set the reference to null. So str2 used to refer to the string avocado, but I can set it to null and change the memory, basically the reference, back so that it's no longer pointing to an object. Having a null reference in Java isn't a problem. Obviously, we've got one here. str2 refers to null. There's no object associated with it, but you do have to be careful because if you try to use an object and it's null, it can throw a runtime error. So take a look at this example where I try to print line the length of str2. Well, since str2 doesn't refer to a string, it cannot have a length. And so when we try to run this code, Java is going to crash with a runtime error saying that we have a null pointer exception. It can't call length because there's no string there to call the length of. If we were ever concerned that a null reference might cause a runtime error in our program, we can actually use an if statement to check the reference's status. So in this example, I asked the question, is str2 null? And if it is, then I can take some action. In this case, I have the user enter a word so that the object will no longer be null. Let's wrap up with an understanding check. So in the code you see on the right, I have three questions. One, how many object references does the code contain? But number two, how many objects does the code contain? And finally, which line in this code is going to cause a runtime error? Pause the video, answer the questions, and when you're ready, we'll go over the answers. All right, for question number one, how many references do we have? The answer is 2. I have a scanner reference called input and a string reference called word. But potentially, there's only one object. Input definitely doesn't have an object because we do not assign it. And at the very least, word attempts to assign an object using input.next. But in actuality, we might not even have an object there because this line, input.next, is going to cause a null reference exception because we're trying to call the next method on a scanner object, and the scanner object was never instantiated. It does not exist, and it is simply null. Now that you've watched this lesson, you should be able to explain how Java stores objects as references and also explain the concept of a null reference.